Hey guys, it's Miss Johnson and I'm here to bring you our notes video for Unit 1 Notes 2. This is Learning Target 2. We are talking about solving equations and proportions today. So now is a good time to find your white notes sheet. Also find something to write with so that you can take notes on your white notes sheet. If you're doing this on Notability, see if you can figure out a way to split screen them, or maybe you watch on a computer and take notes on Notability. Or you could take notes on blank paper, that would work too. Either way, you're also going to want to get your calculator out today. So if you don't have your calculator out yet, you might want to get that out so that you are ready for our examples today. So talking about solving equations, yesterday in our notes, we talked a lot about simplifying expressions and the order of operations. We talked about PEMDAS. Please excuse my dear Aunt Sally. Today we are solving equations. We're going to solve for an unknown variable. There's going to be a variable in each equation that we're trying to isolate and get by itself. And the way we do that is by using inverse operations. So inverse operations are operations that undo each other or cancel each other, such as addition and subtraction. Other inverse operations are multiplication and division. So if you need to undo multiplication, you would divide. If you needed to undo division, you would multiply, things like that. So when we're going through the steps to solve equations, we want to simplify each side of the equation first, make sure we take care of anything that could be combined. Then we need to make sure that we have the variables all on one side of the equal sign. So if there's an x on either side, we need to move that across to the other side. Then the next thing we would do is cancel the constant, and the way we cancel the constant is by using addition or subtraction. And then we would cancel the coefficient by using either multiplication or division. So those are our 4 steps. And remember, if we go through these too fast for you to write, you can always pause the video. So take a minute and pause the video so that you can write down the steps that you need to write down. So let's jump into some examples here. When I take a look at example 1, I see that I have x plus 7 is equal to 12. And I am attempting to solve for that x. X is my unknown variable there. So that is the thing that I need to isolate. If I'm trying to isolate x, that means I need to cancel the addition of 7. In order to cancel the addition of 7, that means I need to do the opposite, which is subtract 7. Now think of your equal sign as kind of like a railroad track. A lot of your teachers in the past may have had you draw railroad tracks down from the equal sign. Whatever you do on the left side of the equal sign, you have to also do on the right-hand side. So if I'm going to subtract 7 over there on the left-hand side, I also need to subtract 7 on the right-hand side. And when I do that, over here on the left, 7 minus 7 is 0. It cancels out and goes away. And all I'm left with is the x by itself, which is what I wanted. On the right-hand side, I would take 12 minus 7. 12 minus 7 is equal to 5. So I end up with x equals 5. Now that was a really basic one-step equation. We're going to try another one-step equation in number 2. In number 2, I have the equation 37 is equal to b minus 29. Now, remember to pay attention to where your equal sign is. So your equal sign is there. Your b, the variable, is on the right-hand side this time. That doesn't change our process. It doesn't matter what side of the equal sign our variable is on. We still use the same inverse operations to cancel what we're trying to get rid of. So I have 37 is equal to b minus 29. The thing that I need to get rid of is all of that, the minus 29. If I'm trying to cancel the subtraction of 29, the opposite of subtraction is addition. So I'm going to add 29 and add 29. And here's where you can use your calculator to support you. 37 plus 29, if you don't want to do that in your head or you don't want to do that out on paper, go ahead and type it into your calculator. I just typed it into my calculator and got an answer of 66 equaling b. So I have b equals 66. Now, again, it does not matter which side of the equal sign you write the variable on. Out of habit, I always rewrite my answer with the variable on the left. So when you see me rewrite it and I've got my variable on the left, there's a reason why. When we get into solving inequalities, that will make more sense as to why I always write my variable on the left. But this is a perfectly fine answer as well. There's nothing wrong with that. You just get used to seeing the variable on the left-hand side. Let's take a look at number 3. I have x plus 9 is equal to negative 3. So here's my variable that I'm trying to isolate. I need to get rid of the addition of 9. Here's my equal sign, so I know that that's what I'm trying to balance on the left and the right. If I'm getting rid of the addition of 9, that means I'm subtracting 9, because the opposite of addition is subtraction. If I subtract 9 on the left, I need to subtract 9 on the right. So that cancels that. I'm left with the x by itself. And negative 3 minus 9 is negative 12. So I have x equals negative 12 for an answer there. Taking a look at number 4, now I have 3 times m is equal to 27. M is still the thing, that's the variable, that's the thing I'm trying to isolate. I'm trying to get m by itself. And it's being multiplied by 3 right now. Since it's being multiplied by 3, I'm going to go ahead and divide by 3 on both sides. Again, here's my equal sign, so I make sure that I do whatever operation I'm doing on the left, I also do on the right. 3 divided by 3 is 1, and 1 times m is not going to change m. M will stay the same. So I have 3 divided by 3, which goes away. That leaves me with m. On the right-hand side, I have 27 divided by 3, which is 9. So my answer here is m equals 9. Now we get into canceling some division. In number 5, I have x divided by 11 is equal to negative 7. X divided by 11. If I am dividing by 11 right now, in order to cancel that, I need to multiply by 11. But since I'm multiplying by 11 on the left, I also need to multiply by 11 on the right. So this 11 on the top cancels the 11 on the bottom and leaves me with x, which is my goal. Here's my equal sign. On the right, I have negative 7 times 11, which is negative 77. So I'm left with an answer of x equals negative 77. It seems funny sometimes to end up with a number that's a lot bigger than the denominator, but if you think about it, if I read this out in words, I would say some unknown number divided by 11 gives me negative 7. So if I'm taking that number and dividing it by 11, it better be bigger so that I get an answer of negative 7. That's kind of what's happening there. All right, let's take a look at number 6. Now I move into two-step equations. So this is an equation. Here's my x variable. I have to cancel the subtraction of 1, but I also have to cancel the multiplication of 5. So separate off your equal sign. I've got the left-hand side and the right-hand side. 5x minus 1 is equal to 9 is my whole equation there. So the first thing that I need to do is I need to get rid of this constant. The constant is that negative 1 there. It's a subtraction of 1. So if I'm going to get rid of that constant, that means I need to add 1 to both sides. So when I add 1, that makes that go away. Negative 1 plus 1 is 0. And adding 0 or subtracting 0 doesn't make any difference. So what I'm left with is all of this stuff, the 5 times the x, and 9 plus 1 is equal to 10. Okay, there's my first step. This was step number 1. Now my second step is I need to divide by that 5. I have 5 times x, so I need to divide by 5 to make it go away. So I'm going to divide by 5 on both sides. That leaves me with x. This was my step number 2, by the way. There's your two-step equation. So 10 divided by 5 gives me an answer of 2. Okay, so two-step equation there. I had to cancel the constant first, then to cancel the coefficient. All right, let's take a look at number 7. In number 7, here, let me try to get this marker out of your way. In number 7, I have 7w minus 3w is equal to 2. So the first thing that I need to do, well, I kind of need that out to change colors, sorry. The first thing that I need to do is, first of all, here's your equal sign. If I look at my equal sign there, my variables are over here on the left, and there are 2 of them. I see 2 variables there. Now, it's technically only one variable. It's the same letter. It's just in there twice. So I can combine these 2 so that I only see my variable one time. I have to do that first. And both of these are on the same side of the equal sign. So I'm not canceling. I'm not moving anything over. All I'm doing is putting those together. 7w minus 3w is 4w. 4w minus 2 is equal to 14. That's what I now have for my equation. Okay, so that was step number 1 there. There's number 1. The next thing that I'm going to do is I'm going to get rid of that constant. I have a constant of -2, so I need to add 2 to both sides. I'm going to add 2 here. That makes that go away. Add 2 on the right, and I'm left with 4w is equal to 16. That was step number 2, by the way. So there's number 2. And then the last thing that I need to do is I need to divide by the 4. If I divide both sides by the 4, I end up with w is equal to 16 divided by 4, which is 4. That was my step 3. So this was a 3-step equation here. 3 steps that I had to take care of in order to get that w by itself. One thing that you can always do if you wanted to check your answer is plug it back into the original. If I take this 4 and I plug it in there and there, every place that you see w, I should be able to simplify and get down to a true statement where 14 is equal to 14. Let's take a look at number 8. Now this one looks a little bit different. Let's take a look at how this one is different. Here's my equal sign right in the middle, okay? I see the variable p over on the left. It has a coefficient of 13. I also see the variable p over on the right that has a coefficient of 5. I have to move those two variables to the same side. I cannot solve for p if it's on 2 different sides in 2 different places. That doesn't work. It doesn't make sense. So the first thing I'm going to do is I am going to take this whole term. It's a positive 5p, so I'm going to subtract 5p over to the other side. Okay, so that's going to make this 5p plus or 5p minus 5p disappear. 5p minus 5p is 0. On the left-hand side, if I combine these, because these are like terms, I have a p variable and a p variable, so I can put those two together. 13 minus 5 gives me 8. So I have 8p minus 3 is equal to 13. All right, so there was step 1. That put my variables together, okay? I'm just marking your steps so that you can kind of see that these are, in fact, multi-step equations here. All right, so now let's look at what we have going on. We have 8p minus 3 equals 13. The next thing I would do is I would get rid of that constant. I need to add 3 to both sides. When I add 3 to both sides, -3 plus 3 goes away. I'm left with 8p is equal to 13 plus 3, which is 16. And then the last thing that I'm going to do, I need a different, brighter color here. Maybe we'll try the gray. It's not really bright, but we'll try it. So the last thing that I would do is I would divide both sides by 8. And I end up with p is equal to 2. So the steps that I had here, I had the first step of gathering the variables together, then the second step was canceling the constant, then the third step was canceling the coefficient, and I'm left with an answer of p equals 2. All right, couple more here. Let's take a look at number 9. So in number 9, we've got a lot of solving that we have to take care of there. The first thing that I notice in number 9 is that I've got some variable or some parentheses. I see parentheses right here on the left-hand side. So I have to take care of those parentheses first. And the way I take care of those parentheses is by distributing that -4. So I end up with -4x. Oh, sorry, that's hard to see. -4x. -4 times 2 is -8 is equal to x minus 18. So remember when we distribute, distribution is multiplication. So -4 times x is -4x. -4 times 2 is -8. Okay, that was step number 1. Step number 2. I see that I have an x on both sides. I'm going to have to fix that. So I'm going to subtract this 1x This is like a 1x. Whenever you see x by itself with no coefficient out front, it has a coefficient of 1. So subtract 1x, subtract 1x, and then negative 4x minus 1x is negative 5x. I still have the negative 8, and I still have the negative 18. This is now gone because 1x minus 1x goes away. I should have drawn my railroad track down for you. Okay. So there's where I'm at. All right, next thing. So now I've taken care of the parentheses. I've taken care of the variables that were on both sides. Now I'm going to cancel the constant. When I cancel the constant, that means I need to add 8 to both sides. So negative 8 plus 8 makes my 8's disappear. I'm left with the negative 5x, so I have less around the x, which is my goal. I'm trying to get that x by itself. Negative 18 plus 8 gives me negative 10. And don't forget, you can use your calculator to support you on those. If you want to use your calculator to help you with that subtraction or addition, especially when negatives are involved, go ahead. There's no punishment for that. So negative 5 times x is the last thing that I need to do. I need to divide by negative 5. Divide by negative 5 on both sides. That's going to go away, and I'm left with negative 10 divided by negative 5, which is positive 2. All right, number 10, here we go. So in number 10, I have 3/7 times x, which is equal to 9. Okay, 9 equals 3/7 times x. So what's happening here is you're technically multiplying by 3 and dividing by 7. That's what happens when you've got a fraction going on. So if I need to cancel the multiplication of 3, that means I need to divide by 3. If I need to cancel the division of 7, that means I need to multiply by 7. And what happens here is you essentially flip the fraction upside down and multiply. Some of you may remember the word reciprocal. Okay, the word reciprocal is when you take the fraction and flip it upside down. So fraction flipped upside down. Okay, so that's a word that you probably have heard before, but maybe you haven't seen in a long time. So that's what's happening here. I need to cancel the division of 7 by multiplying by 7, and then cancel the multiplication of 3 by dividing by 3. And that means my fraction gets flipped upside down. But again, just like every other time we're solving equations, whatever we do on the right, we also have to do on the left. So if I'm multiplying by 7 over 3 on the right, that means I need to multiply by 7 over 3 on the left as well. If you think back to solving fractions or simplifying fractions, this 9 is technically a 9 over 1. And when you multiply fractions, you multiply straight across. So when I multiply straight across, I end up with 7 times 9, which is 63. And then in the denominator on the bottom, 3 times 1, which is 3. Okay. Over here, this 3 divided by 3 cancels. This 7 divided by 7 cancels, and I'm left with just x, which was my goal. That was the whole reason I multiplied by the reciprocal in the first place. All right, I can go ahead and simplify this. 63 divided by 3 is 21, and I end up with x equals 21. Okay. So the last little piece that we're going to talk about today is solving proportions. So we just looked at an example that had a fraction in it, and now we're going to look at solving proportions a little bit more. So a proportion is two ratios that are set equal to each other. So you've got some fraction, like for instance, a over b is equal to some other fraction, c over d. Okay, two ratios, there's 1 and 2. Ratios, the fact that it has a fraction bar, that are equal to each other, there's our equal sign. That's what makes this a proportion. So when we are solving these proportions, we want to cross multiply, meaning we multiply the top on one side times the bottom on the other. We set those cross products equal to each other, and then we solve the equation that remains. So we're going to do this a couple times there. In number 11, I have 4/10 is equal to 32 times x. So if I want to cross multiply here, I'm going to take 4 and I'm going to multiply it by x, because 4 is the top on the left and x is the bottom on the right. So top on one side, bottom on the other. Then I'm going to take the 10 and I'm going to multiply it by the 32, because again, bottom on one side, top on the other. So what that gives me is 4 times x is equal to 10 times 32. That equal sign stays in the middle, okay? All I did was drop that equal sign down. Now I can go ahead and simplify this equation. So 10 times 32 gives me 320. So I have 4x is equal to 320. And then I go ahead and cancel that coefficient by dividing by 4. And when I do that, I'm left with x is equal to 80. And again, you can use your calculator to help. If you wanted to take 320 and divide it by 4 in your calculator, you would get the answer of 80. Now let's take a look at number 12, because number 12 is a little bit trickier. In number 12, I have x plus 4 on the top. What I want you to do is go ahead and group that in parentheses, because those two pieces are together on the top. So I have to group them together so that I take note of that. Same with the bottom. X minus 4 on the bottom is grouped together. It's a group of terms put together. So what happens here is I have to multiply the top on the left times the bottom on the right, and the bottom on the left times the top on the right. So that gives me 3 times x plus 4 is equal to 5 times x minus 4. So now I have two sets of distribution that I have to take care of. Notice, by the way, this step right here on both pieces, when you do the cross multiplying, then your fraction or your proportion ended up being one line of an equation. You got rid of the fraction bars there, and that's kind of the goal. We need to get rid of the fraction bars if we're going to continue to solve this. So now when we got rid of the fraction bars in number 12, flip back over to 12 here, now I have a problem of the fact that I need to distribute on both sides. Here's my equal sign. This 3 needs to be distributed there on the left. So I end up with 3 times x plus 3 times 4, which is 12. Oops, put your 1 in. 3 times 4, which is 12. On the right-hand side, I have a 5 that needs to be distributed. So I'm left with 5 times x, and then minus 5 times 4, which is 20. Okay, so 3 times 4 gave me the 12. 5 times negative 4 gave me the negative 20. All right, next step. So we have a lot of steps going on here, because the next thing that I notice is the fact that I have variables on both sides. I have a 3x on the left and I have a 5x on the right, and that's not okay. I need to put my x terms together. So there's a couple of ways you can do that. You could either subtract 3x over to the right, or you could subtract 5x over to the left. It does not matter which one you pick. I'm going to this time subtract 3x over to the right. The reason I do that is because I know that 3 is less than 5. So I know I'm going to end up with a positive x variable, and I like that. I like working with positive numbers better. So 3x minus 3x goes away. I'm left with just 12 over there on the left. On the right, 5x minus 3x is 2x, and then subtract the 20. All right, next step. Look at all the steps that we had to do. The first step was to cross multiply. The second step was distribute. Now I moved my x terms. Goodness gracious, now I have to go to the fourth step. So the next step is going to be canceling that constant. My variable's over here on the right-hand side. To cancel the constant, I need to add 20. So I add 20 and I get 32 is equal to 2x. Those go away. So that was my fourth step, and check it out, I got one left. I didn't write my 2x. Oof, sorry. Fix that. Go ahead and fix that. I got too excited. Let me go back here. This is a 2x, and I have one step left of dividing by 2. When I divide by 2, 32 divided by 2 is 16. So goodness gracious, after 5 long steps, I end up with an answer of x equals 16. All right, that takes us to the end of our slides for today. Thanks for listening to our notes video. Let me know if you have any questions with anything, and go ahead and work on your practice assignment, and I'll catch you next time.